the factor that is measured. Control. If the exam question simply says, identify the independent, dependent, and controlled variables in an investigation, write independent variable, the factor that is changed; dependent variable, the factor that is measured; controlled variables, the factors that are kept the same. If they give you a specific experiment, then apply those definitions to the experiment. Example, investigating how temperature affects the time taken for sugar to dissolve. Independent variable, temperature of the water. Dependent variable, time taken for the sugar to dissolve. Controlled variables, amount of water, size of sugar cube, stirring rate. That's the level of answer CCEA usually wants. For this type of question, hypothesis prediction. A hypothesis is an educated guess about what you think will happen. Example, open quote, as the temperature of the water increases, the sugar will dissolve faster. Close quote. Reasoning, explain why you think this will happen. Example, open quote, this is because particles in hotter water have more energy and move faster, causing the sugar to dissolve more quickly. Close quote. Easy formula for any investigation. Open quote, prediction. As the independent variable increases, decreases, the dependent variable will increase, decrease. Reason, because of the scientific idea that explains it. Close quote for 2 marks. 1. State what you think will happen. 2. Give a scientific reason why. For a question like, plan a method to allow their hypothesis prediction to be tested, CCEA wants a simple, fair test method. A good answer structure is 1. List the equipment needed. 2. Change the independent variable. 3. Measure the dependent variable. 4. Keep the controlled variables the same. 5. Repeat and calculate an average. Example, temperature and dissolving sugar. 1. Put 100 centimeters of water into a beaker. 2. Heat the water to 20 degrees Celsius and add 1 sugar cube. 3. Measure the time taken for the sugar to dissolve. 4. Repeat at 40 degrees, 60 degrees Celsius, and 80 degrees Celsius. 5. Keep the volume of water, size of sugar cube, and stirring rate the same. 6. Repeat each temperature 3 times and calculate the average time. If it's a 4 to 6 mark planning question, make sure you mention what you change, what you measure, what you keep the same, repeats for reliability. An A-star answer template for plan a method to allow their hypothesis prediction to be tested is, open quote, use suitable equipment to vary the independent variable over a range of values. Measure the dependent variable accurately each time using appropriate apparatus. Keep all controlled variables the same to ensure a fair test. Repeat each measurement at least 3 times and calculate a mean. Record the results in a table and compare the results to determine whether the hypothesis is supported. Close quote. For a specific investigation, replace independent variable, dependent variable, and controlled variables with the actual variables from the experiment. This wording covers the key marking points examiners look for: method, fair test, repeats, and recording results. For carry out a risk assessment on all planned practical activities, an A-style answer is, open quote, identify any hazards involved in the investigation, describe the risks associated with each hazard, and state appropriate control measures to reduce the risk. Wear suitable safety equipment, such as eye protection where necessary, follow laboratory safety procedures, and ensure equipment is used correctly. Close quote. Example, if using hot water, hazard, hot water, risk, burns or scalds. Control measure, handle carefully, use heat-proof gloves if necessary, and allow water to cool before disposal. The key formula is hazard, risk, control measure. For select suitable equipment/apparatus that will allow them to obtain appropriate and accurate results, an A-star answer is, open quote, Choose equipment that is appropriate for measuring the variables being investigated and that provides sufficient accuracy and precision. Use measuring instruments with suitable scales and resolutions to minimize uncertainty and improve the reliability of the results. Close quote. Examples: measuring volume, measuring cylinder; measuring temperature, thermometer; measuring time, stopwatch; measuring mass, balance. The examiner is looking for appropriate equipment plus accuracy, precision. Four, produce a results table with appropriate headings and units for recording a suitable extent and range of data. An A-star answer is, open quote, draw a table with clear column headings, including the name of each variable and its unit in brackets. Record a suitable range of values for the independent variable and the corresponding measurements of the dependent variable. Include repeat readings and a mean value where appropriate. Close quote, example layout. Temperature G, time to dissolve S. Trial 1, Trial 2, Trial 3, mean range of values, 20 readings 40, 60, 80. Key things examiners look for: headings, units in brackets, range of values, repeat readings, mean where suitable. For demonstrate understanding of the steps that must be taken to ensure the reliability of data collected, an A-star answer is, open quote, repeat measurements several times, identify and disregard any anomalous results, and calculate a mean value. Use the same method and equipment throughout the investigation to ensure consistent results. Close quote. Keywords to include repeat readings, anomalous results, mean average, consistent method. Those are the marking points CCEA typically looks for. For this practical, an A-star answer would mention the correct steps and safe use of equipment. 1. Place a thin sample of the cell tissue on a clean microscope slide. 2. Add a drop of water or stain if required. Lower a cover slip gently at an angle using a mounted needle to avoid air bubbles. 4. Place the slide on the microscope stage and secure it with stage clips. 5. Start with the lowest power objective lens. 6. Use the coarse focus first, then the fine focus to obtain a clear image. 7. Increase magnification if needed, and use the fine focus to sharpen the image. 8. Handle slides and cover slips carefully to avoid breakages and clean up any spills promptly. Keywords: cover slip, air bubbles, low power first, coarse focus, then fine focus. Handle glass safely. For investigating the energy content of food by burning food samples, the key practical skills are: 1. Measure a known volume of water and place it in a boiling tube, test tube. 2. Record the initial temperature of the water. 3. Weigh the food sample. 4. Mount the food on a needle or pin and ignite it safely. 5. Hold the burning food beneath the tube containing water. 6. Allow the food to burn completely, then record the highest water temperature reached. 7. Calculate the temperature increase. 8. Reweigh any remaining food if required. Safety. Wear eye protection. Tie back long hair. Take care with naked flames and hot equipment. Key skills exam points: measure volume accurately, measure temperature correctly, burn the food completely, and use the temperature rise to compare energy content. For the CCEA Practical Skills Assessment, the specification point isn't just memorizing the reagent and color change. You should know the method as well. Sugar. Benedict's test. 1. Add Benedict's solution to the food sample. 2. Place the test tube in a hot water bath for a few minutes. 3. A positive result is a change from blue to green, yellow, orange, or brick red. Starch iodine test. 1. Add a few drops of iodine solution to the food sample. 2. A positive result is a change from orange-brown to blue-black. Protein biuret test. 1. Add biuret reagent to the food sample. 2. A positive result is a change from blue to lilac purple. Fat emulsion test. 1. Add ethanol to the food sample and shake. 2. Add water and shake again. 3. A positive result is a white milky emulsion. For the practical exam, you should be able to use the correct reagent, carry out the method safely, recognize the positive result, record the result correctly. That's typically the full level of detail CCEA expects for this practical skill. For investigating the need for light and chlorophyll in photosynthesis, you should know the practical method. Need for light. 1. Destarch a plant by keeping it in the dark for 24 to 48 hours. 2. Cover part of a leaf with opaque black paper. 3. Place the plant in sunlight for several hours. 4. Remove the leaf and boil it in water. 5. Heat the leaf in ethanol in a water bath to remove chlorophyll. 6. Rinse the leaf in warm water. 7. Add iodine solution. Result: the part exposed to light turns blue-black, starch present. The covered part remains orange-brown, no starch. Need for chlorophyll. 1. Use a variegated leaf, green and white areas. 2. Expose the plant to sunlight. 3. Remove the leaf and boil it in water. 4. Heat it in ethanol in a water bath to remove chlorophyll. 5. Rinse in warm water and add iodine solution. Result: only the green areas turn blue-black. The white areas remain orange-brown. Conclusion: light and chlorophyll are both required for photosynthesis because starch is only produced where they are present. For following a neutralization reaction by monitoring pH 2.1.11, know this method. Place a measured volume of acid in a beaker. 2. Measure and record the initial pH using a pH probe, pH meter, or universal indicator. 3. Add the alkali in small amounts, stirring after each addition. 4. Record the pH after each addition. 5. Continue until the pH reaches 7 neutral and then slightly beyond. Results: acid pH less than 7, neutral pH 7, alkali pH greater than 7. What you're looking for: the pH increases as alkali is added. The neutralization point is reached when the pH is about 7. Practical skills: measure volumes accurately, read pH values correctly, record results in a table, wear eye protection when handling acids and alkalis. For the practical paper, they often ask about the apparatus, pH probe, universal indicator, measuring cylinder, identifying the neutralization point, drawing, interpreting a pH versus volume graph. For investigating the reactivity of metals, 2.8.4, know this practical. 1. Place equal volumes of dilute acid into separate test tubes. 2. Add equal-sized pieces of different metals, e.g. magnesium, zinc, iron, copper. 3. Observe the reaction and compare how vigorous it is. 4. Record observations such as fizzing, bubbles produced, temperature change, or time taken for the metal to react. Results: more reactive metals react faster and produce more bubbles of hydrogen gas. Less reactive metals react more slowly or not at all. Typical order of reactivity: magnesium, zinc, iron, copper. Safety: wear eye protection. Handle acids carefully. Keep test tubes pointed away from people. Key practical skills: use equal-sized metal pieces. Use the same volume and concentration of acid. Make fair comparisons between metals. Record observations accurately. For investigating the temperature changes that occur during a reaction, 2.8.7, know this method. 1. Measure a known volume of reactants and place them in a polystyrene cup or insulated container. 2. Record the initial temperature using a thermometer. 3. Mix the reactants. 4. Record the highest or lowest temperature reached. 5. Calculate the temperature change. Results: if the temperature increases, the reaction is exothermic. If the temperature decreases, The reaction is endothermic. Practical skills. Read the thermometer correctly. Stir the mixture to ensure an even temperature. Record temperatures accurately. Use an insulated container to reduce heat loss. Safety. Wear eye protection. Handle chemicals carefully. Be aware that some reactions may produce hot solutions. For investigating how changing a variable changes the rate of a reaction, 2.9.7, know this general method. 1. Choose one variable to change, e.g. temperature, concentration, surface area, or catalyst. 2. Set up the reaction and measure how fast it occurs. For example, by timing how long it takes, measuring gas produced, or observing when a cross disappears. 3. Repeat using different values of the independent variable. 4. Keep all other variables the same. 5. Record the results and compare reaction rates. Results: higher temperature, faster reaction. Higher concentration, faster reaction. Greater surface area, faster reaction. Adding a catalyst, faster reaction. Key practical skills: change only one variable. Keep the test fair. Measure time or reaction progress accurately. Repeat and calculate a mean for reliability. For using electrical circuits to measure the voltage and current passing through a wire, 3.1.8, know this method. 1. Set up a simple circuit with a power supply, wire, ammeter, and switch in series. 2. Place the ammeter in series to measure the current through the wire. 3. Connect a voltmeter in parallel across the wire to measure the potential difference, voltage. 4. Switch on the circuit and record the readings from both meters. 5. Change the length or type of wire if required, and repeat the measurements. Results: current is measured in amps, A. Voltage is measured in volts, V. Practical skills: ammeter must be in series. Voltmeter must be in parallel. Read scales accurately. Ensure correct circuit connections before switching on. For using electrical circuits to demonstrate Ohm's law, 3.1.10, know this method. 1. Set up a circuit with a power supply, ammeter in series, voltmeter in parallel across the wire resistor, and a fixed resistor or wire. 2. Start with a low voltage and record the current and voltage. 3. Increase the voltage in steps using the power supply. 4. At each voltage, record the current. 5. Repeat readings and calculate averages if needed. 6. Plot a graph of current A against voltage V. Results: as voltage increases, current increases in direct proportion for a fixed resistor. The graph is a straight line through the origin. Conclusion: this shows Ohm's law. Current is directly proportional to voltage at constant temperature. Practical skills: ammeter in series, voltmeter in parallel. Take multiple readings over a range. Keep temperature constant. Record results accurately in a table. For investigating the heat conductivity of different materials, 3.1.11, know this method. 1. Take rods of different materials, e.g. metal, glass, plastic, of the same size. 2. Fix drawing pins along each rod using wax at equal distances. 3. Heat one end of each rod using the same heat source. 4. Observe the order in which the drawing pins fall off as the wax melts. 5. Record the time taken for each pin to drop or the order of falling. Results: good conductors transfer heat quickly, pins fall off faster. Poor conductors transfer heat slowly, pins fall off later or not at all. Practical skills: use rods of equal length and thickness. Apply heat at the same position for each rod. Keep conditions fair. Record observations clearly. Order, time. For investigating reaction times, 3.7.5, know this method. 1. Have a partner hold a ruler vertically with the 0 mark at the bottom. 2. Place your hand near the bottom of the ruler without touching it. 3. Your partner drops the ruler without warning. 4. Catch the ruler as quickly as possible. 5. Record the distance the ruler fell before being caught. 6. Convert distance into reaction time using a scale or repeat with multiple trials. 7. Repeat several times and calculate a mean. Results: smaller distance equals faster reaction time. Larger distance equals slower reaction time. Practical skills: ensure ruler is released randomly, no warning. Keep hand position the same each time. Repeat readings for reliability. Record results accurately in a table. For obtain and record accurately sufficient experimental evidence to test a hypothesis prediction, an A-star answer would be, open quote, carry out the experiment carefully, taking accurate measurements of the dependent variable for a suitable range of the independent variable. Repeat readings at least 3 times to improve reliability and record all results clearly in a table with correct headings and units. Close quote, this covers what examiners want: accurate measurements, enough data, range, repeats, clear recording in a table, link to testing the hypothesis. For demonstrate understanding of the mathematical techniques which can be used to identify the relationships between variables, an A-star answer is, open quote, use graphs and calculations to identify patterns between variables, such as plotting one variable against another to see if there is a linear relationship. The relationship can be described using proportionality, direct or inverse, or by calculating gradients to show how one variable changes with another. Close quote. What CCEA is really looking for: plot a graph to spot a pattern, identify if it's directly proportional, straight line through origin, inversely proportional, curved relationship, use gradient slope to show rate of change between variables. If you want a shorter exam-style version, open quote, plot a graph of the variables and analyze the pattern. A straight line through the origin shows direct proportionality, while a curved graph shows a non-linear relationship. The gradient can be used to show how one variable changes with another. Close quote. For demonstrate understanding of what is meant by an anomalous result in a set of experimental data and how it should be treated, an A-star answer is, open quote, an anomalous result is a value that does not fit the pattern or trend of the other data. It should be identified, checked for possible errors, and usually ignored when calculating the mean if it is clearly incorrect. Close quote. Key points examiners want: doesn't fit the pattern, likely due to error, identified and noted, excluded from mean if justified. An anomalous result is a result that does not fit the pattern of the other data. It may be due to an error in measurement or procedure. It should be checked for mistakes, and if it is clearly incorrect, it is usually ignored when calculating the mean to avoid affecting the overall result. Open quote, a conclusion is made by stating what the results show and linking it directly to the hypothesis. It should be supported using evidence from the data collected, describing any clear patterns or trends, and stating whether the hypothesis is supported or not. Close quote. Open quote, analyze and interpret the data by identifying patterns, trends, or relationships, and using this evidence to explain what the results show. Critically evaluate the data by considering its reliability and validity, including any anomalies, sources of error, and whether the method produced accurate results. Close quote. Here's a CCEA Single Award Science Practical Maths cheat sheet, one-page style. This is what you actually need for practical papers. Hashtag core calculations. Mean, average, mean, frac, text sum of values, text number of values, used when repeating experiments. Percentage change, frac change original times 100. Change, difference, text final, initial. Physics, general practicals, speed, frac, distance, time. Density, correct mass, volume, weight, force, text mass times gravitational field strength. Energy transfer, basic forms used in practicals. Energy equal text time. Electrical power, Power's voltage, times Ohm's law, voltage current, times resistance. Chemistry practical skills, often linked to maths use. Gas production rate, indirect maths. Compare volume of gas versus time, or time taken for reaction. No fixed formula, but you may graph or calculate rates. Graph skills, very important. Gradient, slope, gradient change in y, text change in x. Used for speed from distance time graph, rate of reaction, Ohm's law graphs. Hack unit conversions you need. 1 centimeter cube equal 1 milliliters. 1,000 milliliters equal 1 L. 1,000 grams equal 1 kilograms. Degree C stays degree C, no conversion needed. Seconds S, minutes min, hours H. What examiners really want: correct formula, correct substitution, correct answer with units, working shown, correct rounding, usually 2 to 3 significant figures. If you want, I can also give you a most common practical exam questions plus model answers sheet that basically guarantees marks. Open quote. Reliability can be affected by the number of repeats, the presence of anomalous results, and how consistent the method and measurements are. If measurements are not repeated enough times, or if readings vary widely, the data is less reliable. Using precise equipment and repeating results to calculate a mean improves reliability. Poor control of variables or inconsistent technique can also reduce the reliability of the evidence collected. Close quote. Open quote. Develop a conclusion or explanation that is supported by the data, but also considers its limitations. This includes recognizing the reliability and accuracy of the results, any anomalies or errors, and whether the evidence is sufficient to fully support the conclusion or hypothesis. Where limitations exist, explain how they may affect the results and how the investigation could be improved. Close quote.